Thanks for coming. I'm Francesco, and this is Decentralized Finance 101. Actually, this presentation has a second title, which is actually Decentralized Stablecoins 101, a presentation about DAI. And DAI is a scary word, but it's actually not. It's a token, and we will see. So this presentation includes two stable things. One is stable coins, and another one is stable diffusion. Stable diffusion, just briefly, I don't want to spend all the time on it. It's an AI that generates image from text, and it dreams about things. This is what stable diffusion thinks the blockchain is, and this is how it imagines Porto. You can see, this screen has very bright color, but it looks a bit better. And yeah, people are doing sort of crazy stuff like this, like videos, and it's getting better and better. So I will put some slides on it. Then this is a personal view, so not affiliated with my company. And in this presentation, I will cover three things. So not only DeFi, it's Bitcoin maximalism and Ethereum, DeFi today, 101, so stable coins, and we will see some code, because I guess you are mostly developers, so you want to see code, not just blah, blah. And before we start, briefly, I'm a CTO of Applied Blockchain, and I'm into Bitcoin development from 2013. And I'm a Bitcoin and Ethereum maximalist, especially Bitcoin. This is how the AI views Bitcoin maximalist. So what is a Bitcoin maximalist? Reddit thinks it's something scary as this, and this is even scarier, but it's probably accurate. So a Bitcoin maximalist is somebody that wants to shield the new buys from all the bullshit that is in the blockchain space. Because Bitcoin is money, and it's rare that alts outperform BTC, like most of the alts. And so the thing shortly is don't invest in alts, period, presentation finished, thank you. Obligatory AI image is a bit over-sharpened, but over-saturated, but yeah. So imagine I told you instead, yay, blockchain, wow, DeFi, 100 million coins, new, one every day, wow, amazing. Or I can do even better, I can shield my coin, I'm launching a new coin, make void coin, the sale starts now. Deposit here, please, all your BTC, thank you. Presentation finished. No, it will be bad. So hopefully you won't fall for these, and you hold the BTC, you build on Bitcoin and Lightning Network. I've done my duty as maximalist, I've warned you, and now I will explain why I'm an Ethereum maximalist. So, if Bitcoin is money, why we need Ethereum? Why we need people that support Ethereum over the other things? Unfortunately, Bitcoin is not very flexible. It's not the most flexible thing. So try to build a decentralized stablecoin, so DeFi things, on top of Bitcoin. Like you could put a lot of technologies, RGB, LN, multi-sig time locks, probably a server, so it won't be very decentralized. So maybe just use Ethereum, and it has been built for it. Bitcoin scripting is kind of limited. Ethereum, instead, is built to be programmable. Ethereum uses a language that is called Solidity. Solidity looks like JavaScript. So yeah, I know that JavaScript is not the best language, and that's another presentation. Yeah, you have a class which is called contract in Solidity. It's called simple storage, so it's just a setter and getter example, and you have an internal, so you have uint, in this case you have a class variable, so it's some data that gets into the instantiated object on the blockchain. The blockchain it's a little bit different, so it works so that when you instantiate the class, so when you deploy the contract, the class has some space, and this space is the class variables. So when you instantiate, the instance variable will be stored inside, let's say, referenced inside your smart contract, and you have some methods look like JavaScript, but we won't do Solidity today. Solidity have tons of quirks that I don't want to go into. So we'll just use JS. And between the programmable blockchains, why? Because not only has this very, very easy, simple language, but has the biggest market cap and a good toolkit, the developer adoption. If you Google, you will find a lot of materials. There are many chains which are forks of Ethereum, so they behave like Ethereum. They are Ethereum Virtual Machine, EVM, compatible, and they use Solidity. So, long story short, use Ethereum to build all. And let's see some DeFi. And you can switch off the volume of your phones, thanks. Okay, sorry. So what is level 0? So if Bitcoin is, so Bitcoin is already DeFi. That's level 0 of DeFi in my opinion. Because Bitcoin is money and it's already decentralized. This means that when you send a transaction in Bitcoin, you are sending it directly to the recipient. There's no authorization to do to any third party. You just send the money peer-to-peer. And it is programmable, so you don't have a server, a central server. You can run your node, or you can use public nodes. You can send your signed transaction there, and you can use features like Bitcoin scripting or multi-sig time locks, etc. Unfortunately, this presentation is around DeFi. I would like to have talked about Bitcoin, but okay, this is at least I had this intro. So DeFi, what do people mean when they say decentralized finance? They mean mostly things that you can do on Ethereum or on other blockchains which are programmable. And this is the list. So I will speak about decentralized stablecoins, but there's much more that you can do. Exchanges, lending pool, more advanced system, but be aware of some of them because staking and liquidity and yield farming are I mean, I won't say the names. Not all of them are scams, but be wary, be wary. So if Bitcoin is level 0, what is level 1? It's stable coins. So sorry, decentralized stable coins. This is an uncomprehensive list, like a non-comprehensive list of stable coins, of the biggest ones that we have, like USDC, which is backed by Circle, USDT, which is called Tether, which was on Mastercoin, which is a protocol built on top of Bitcoin, but now it's on Ethereum, and many USDX, and some of them went very badly, but I won't discuss on that because most of these are centralized except the latter, which is the MakerDAO DAI project. So there is a project by this group, MakerDAO, and their aim is to do a decentralized dollar, and it was the first project and is currently the biggest one, so the one with most liquidity. So how does it work? It basically works around the concept of smart contracts and locked cryptocurrency. So these smart contracts, thanks to the power of signatures, these smart contracts can have crypto locked inside it, and they can behave. They can have some rules so that the money can be unlocked only if these certain rules are met, and these rules can be programmed by the developers. Okay. So the simplest US dollar, because a premise, if you send ETH or BTC or any other crypto, you have the problem that the value fluctuates. So why do we need a stable coin, like in short? Because so we can know the amount that we can transfer without having this volatility. And the first version of DAI, the first version of this blockchain dollar on Ethereum, is actually, it works a bit like this. So you have some ethers in the smart contract, and you get $1 for a bunch of ethers. In this case, let's say, to simplify, because how it's really made, it's very complex, and this is like ground-to-earth presentation. This is very decentralized stablecoins 101. So we want to keep things simple. So you have some ethers locked into this contract, and these ethers are more than the value in dollar that you get. So you get some tokens back, but inside the contract there's more value in ethers than what you get back. And that is called over-collateralization. Hard word. So inside this contract, there's ETH, and then you get one DAI, which represents $1. And this is the SAI, not the DAI, so this was the previous version, which is a single asset. But now, the current version is even more complex in terms of smart contract, and you have a lot of crypto assets, mainly USDCs, ETH, and wrapped Bitcoin inside this pool, and then you get the DAI back. So, the baseline is that it's decentralized, so no single party, MakerDAO or the other actors in the system can take it. They can get DAI only if they put crypto inside. Then it gets even more complex because you can imagine that blockchain is a closed system. So when you have data inside the blockchain cannot really talk to the outside world. It needs somebody to push some data inside this network. So there are a set of parties, like relayers, like in practical terms, companies hosting services, and probably they have some price feeds, so they're market feeds. So you can imagine that ETH, BTC is traded, and the market price changes like minute to minute, and these parties are pushing price information for each asset inside a smart contract. The smart contract then takes the average of the price, and it gets the value of the crypto locked inside the smart contract. This was a very, 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 very simplified explanation, and this is not even the second version. This is the first version, and it's already complex. Like if I would explain how this in circle and the one in the middle are all contracts, so I would go on every contract, look at all the methods, look at what they do. I mean, it is complex. This is Decentralized Stablecoins 101, so yeah. Okay, so I spent 10 minutes on this, and I hope that this intro was useful. I know that it's a lot of information. But now my duty as a presenter is done, so I finally can do my presentation, because I've shown you the DeFi 101, and finally we can have a look at some code. So, first, not to show any code yet. So I have one question. Which third world country do you think it will benefit from holding US dollars? It's a joke, by the way. It's an image generated by OpenAI. OpenAI is a commercial version of these AIs, but yeah. I'm not sponsored by OpenAI, unfortunately. So yeah, maybe you missed what's going on in the world economy. Because you are one, it's called Europe. So this is the current chart. This is the appreciation of euro and pound over the dollar in the past year. So you can see, yes, it's going well. It's going well. Okay, now at least you have one reason to code a smart contract. So imagine that I have a goal. My goal is to inspire you, okay? Bring you into places. Before Bitcoin, developers could program just via API. So you had to use PayPal, you had to use Stripe, maybe you had to use like a point of sale API, you know, the one that then talked to COBOL servers, mainframes. Like, do you think it's fun? Do you think it's pretty? But no, with Bitcoin and Ethereum, you can program money directly, like no COBOL involved. Wow, amazing. You're on top of the mountain. Have you ever coded a wallet? Hello, I'm Make Void on GitHub, on Twitter. My DMs are open, so you can contact me. And I specialize in wallet development. Maybe you don't know, but the other reason is that wallet development is extremely easy. That's another good reason why you should build one. Now, obligatory warning, there's tons of code. Ready? this is the presentation that I want to do, how to build a DeFi wallet. Example in JS. And to build a wallet that is not just a toy, we are going to use Polygon, not Ethereum. You can use Ethereum testnet, you can use the real Ethereum, but the Ethereum has a downside at the moment, which for testing is not great because the dollar value of one transaction is currently $2. On Polygon, which is the one that I will show, is 1 cent. So I recommend Ethereum, but because of transaction fee, the presentation code uses Polygon. Switching, by the way, it's very easy. Okay, let's build a wallet. Developer hat on. But yeah, the AI, I don't know why, but it cannot render a wallet. Every time I said wallet, this time it put a coin here, but yeah, this was supposed to be a wallet inside a screen, but yeah, whatever. It will work at some point. Okay, so on this presentation, we'll use JavaScript. This is how the AI imagines JavaScript. A lot of packages, probably NPM. React Native or Cordova, but the React Native image was much cooler. Cordova wasn't so good. We have some mockups, but we won't do the UI. We'll just use JavaScript to do the underlying code so you can run it on Node. So this is a very bad mockup. It has a QR code, receiving address. So if you scan it, you can send money to you. Then you have the amount, the balance, and a send button, very styled send button. If you click on the QR, it goes and it maximizes, so you can scan it and copy the address. And then if you click send, this nice button at the bottom, you have an address that you can paste, probably a camera, but yeah, don't bother about the camera, the scanning functionality, and then you go forward, you put the amount, loading screen, which can be 1 minute, but then later you get the transaction done and you get a success screen. So roughly it's like 2 screens, one is with a wizard, and we'll see that you can build this only with 50 lines of JS. Crazy. Crazy. Okay, and of course you can test it on browser and you can deploy it on mobile. Okay, I'm a bit ahead on the presentation. So the library that I'm going to use for this build is called Web3.js. There is another library which is called Ethers.js. They're both very good, I think. This was the first one, so npm install, and we require it, so nothing major, it's just normal requires. This is for simplicity, but you can change this line. So you require it, and then you connect to a node. Of course, if you were hosting your own node, this would point to your provider, to your own node. In this case, we are using Polygon, but Cloudflare has also a node hosting, and there are many more, some premium and some free. And you instantiate a connection and you instantiate an account. The account won't be a remote account, but it will be on your machine. So in the case of the mobile device, it will be potentially on a secure storage on your mobile device. But for the sake of simplicity, we'll generate an account and save it into a text file because we are just playing with it, and this is not relevant to the presentation. So .create creates an account which is formed by a private and public key, and there is a nice representation of this public key, which is the address, and I mean, it's still an hexadecimal number, so it's not super nice, but at least it's shorter than the private key. So yes, and then you can read it with this code, and private key to account loads back your private key that, in the case of the mobile, it is inside probably the secure storage of your device and not in a plain text file. But for now, we're just playing. So the address loaded will be the same as the one generated. Then we open an async block. Very fun in JavaScript, yes. And okay. So this is the first RPC call. So the magic happens all in one line. So ETH is the connection. We've seen that before we instantiated the account. So this is actually an RPC call. It means that the application will call via JSON RPC your node or the public node, and it will execute an RPC API called ETH get balance. I mean, it's also in JavaScript, but the RPC call is called ETH get balance. And passing your account address, you will get the balance of your account. The balance is in this unit called way, and way is because Alway is, I don't want to butcher his name, but yes, it's basically based on this famous guy, and it's the smallest unit. So in Bitcoin, probably you have heard of Satoshi. So in Bitcoin, they called, because they have their idol, the creator of Bitcoin, called Satoshi with the smallest unit, and now they put Alway, if I'm not mistaken, as the unit, the smallest unit in ETH is the way, and this is just a helper to convert the smallest unit to the bigger unit, which is Ether. And in this case, because it's Polygon, there are no Ethers on the base currency, but the currency is called Matic. So when you run this code, you will get the address logged, then getting balance, and after a very short time, usually the API is very, very, very fast on the nodes, even the public ones, and you will get the balance. So super, super easy so far, no? Like one RPC call and you are ready into blockchain. I mean, cool. No? Are you not excited? Oops. So what is this? Wow. Oh, this is a blob of text. Don't worry. You don't have to code it or memorize it. You just Google ERC20 Ethereum. So this is the prerequisite to the smart contract development. So you have to get this is called ABI, Application Binary Interface, and it's essentially the list of all the methods available that your contract can call. You just Google it, get it, or get it from the Explorer. So now that you have it, you need another set of things, which is some conversion. So we did one before, and you need to convert the value that you want to send. So we are sending $1 cent, and then you have this gas price, which is really like fuel price. So it's the amount of money that you need in Matic or in Ethers to be able to send the transaction, because the transactions are not free in the blockchain world. So you have to pay the miners or the validators for their work. So, okay, moving on. Okay, this is really how to interact with the contract. So every contract, as I said, the deployed contract, so these classes are instantiated as an object, okay? And this is the memory pointer to it. So it's true that blockchain is decentralized, but when you talk to a RPC node or when you talk to your own node, you have actually one memory space. So you have all the blockchain state that you can query. And this is the memory address of a specific class instantiated on the network. So, sorry, on this memory space. I know it's a bit mind-bending, but you can think about Ethereum being like a local computer, and all the classes that you instantiate live as deployed contracts or instantiated objects, and you can access them. So, probably this is powered by blockchain, that's why it flickers. So we are now accessing the instance, so this could be called the DAI contract instance, and all the balances and all the methods to transfer the DAI, the USDs, are inside this. So we instantiate it. We have to pass the ABI, this address, and your address. And then we can see the first and only method that we need. So we have already like implemented the receive screen because we got the address. We put a QR code based on the address. We put the receive screen, there is the address on the bottom. And now we are going to implement the send screen. roughly, I mean, the implementation of the send screen is this. I mean, of course, there's the lines before, but what are these? 3 lines of code? I mean, it's simple. Unfortunately, there is more complexity which is required, so there is some boilerplate, but it's not much. So to actually call the method, so that was to construct the method call, and these are the required parameters, and they need to be passed with particular values. So we have seen before the gas price, so things that we don't know. Gas price, which is the transaction fee that you need to pay for the network. This is a fixed value. This fixed value is different for every method. For this particular method is around this number. And then you have the call data, which is the method call that we constructed before. And then you have the address, and you notice that in 2, we don't put the address of the recipient, but we put the address of the contract. Okay, this is just all to flash these things, this code inside your brain. Okay, it's all a technique. It's psychology. I mean, it's not technical issue. Okay, so finally we have the transaction built as all these parameters, and we pass them here. Account is the other thing that we instantiated. So ETH is the RPC. Account instead is what contains your private key. So first, you will need to sign a transaction. So this will use your private key, do an ECDSA signature, and it will create a raw transaction, so a very, very big blob of text containing all the parameters encoded. And then this is the actual RPC method. So the one before, I was wrong. The one before was just to construct it, but this will send it. So this will contact the node and send this big blob of text, and we will get a receipt. We will get another smaller blob of text, which is called the transaction hash. But for friends, it's TXID, so transaction ID. It's the identifier of that transaction, and because it's an identifier, it's unique. So this long here is a transaction I made this morning, sending 1 cent to me, because I mean this is a presentation, and I like to not lose coins sending it to random addresses, because you can, and like there are bugs in code, and there are horrible stories of sending money to random addresses in production. But I'm not here to talk about those, even if they are funny. So you had a link here. So transaction hash as a get parameter of this REST URL. So etherscan.io, or there are many other blockchain explorers, and they just run nodes, monitor the blockchain, and there is some confirmation time, and finally you have your transaction confirmed, and your send transaction method await will finish, and you have all the nodes essentially synced to your transaction, and the money will be sent. So we sent 1 cent to ourselves. Ooh, we made it! I told you it wasn't complex. I mean, it's still code, so there is some complexity, but it was roughly 50 lines of code with all the boilerplate, so it's pretty easy, no? I mean, JavaScript is easy, so... Okay, yeah. You want to be a blockchain developer? It's easy, no? But yeah, if you want to work with me, I have to plug the company now. Sorry. Play blockchain/join. I know that they put the talk because they knew that I would plug the company. So like they put the talk right before lunch. So you are all starving probably. Why am lost? I'm listening to this guy. Anyway, I'm the CTO of Applied Blockchain. We are based in London, Porto, and we have remote positions. We are devs. Very oversaturated. No, I'm joking. No, we are not devs. We are happy bots. These are just generated by the AI. When you say, programmers. Yeah, the office in London has a view. We do code retreats there, and we have a ship. No, I'm joking. We have an actual office. It's in Porto Battaglia. I think here, Regus. Anyway. And remote is important. Continue to plug, or questions? Continue to plug. We have pizza teams, Node.js on the front and back and full stack everywhere. Stack is Node.js, Core, React, React Native, TypeORM, KNX, Ethers.js, Postgres, Redis, AWS, EKS, Tools, Datadog, Papertrail, Sentry, AWS, Slack, GitHub, Google, Circle CI, Docker Hub, NPM. Woo! Thank you. Questions? Can be anything. I can go back in the presentation. Yeah. Good question. How do you know the gas price? So, there are many ways, but okay. Going back, so you can see here I'm on Polygon scan, but there is one for Ethereum. It's called Etherscan, and those are called block explorers. So they are websites that can show you the information inside the chain. So the easiest way as a user to see the gas price is to go there, and in the menu they have a section called gas price estimation. So you can see by various time frame, like 1 minute, 15 minutes, 30 minutes, like depending on the rush that you have to send this transaction, they give you different gas prices, so different transaction fee that you need to pay. If you pay less, your transaction may be delayed. So this is to balance essentially, like the blockchain is a decentralized system, so the miner choose only the highest paid transaction. So if you pay too low and the network is congested, your transaction will not be included. But if you pay a good amount of fee, it will include it in the time frame that you want. And the APIs, so Web3 or Ethers.js, the APIs have also RPC call on the node that does the gas estimation. But as a user, you may just want to go on the Explorer, so etherscan.io or PolygonScan for Polygon, or yeah, there are many. And they have a section where you can see the recommended gas price for the moment. It always changes, and the technique that you use as a wallet developer is try with a gas price. If the transaction doesn't confirm, you can ask the user to bump the fee. So if you resubmit the same transaction, the fee won't be paid twice. Only the transaction with the highest fee will be counted. So, yeah. Simplified. Yes? Exactly. So that's a very good question. I didn't want to go on the details, but how can we prevent a stablecoin system dropping to zero like happened on Terra Luna, TUSD? Like what I've shown, hopefully, MakerDAO DAI is an attempt to fix it, because with Tether, Circle, Luna, Terra, the system is completely centralized. So in a decentralized system, there's still risk. There's still, like the Oracle, the pricing thing, if somebody manages, like an attacker manages to manipulate that, you could do damage on such a system, even if it's decentralized. But it is better. Like you have a more resilient, it's more resilient because it's decentralized. But yeah, that's why my presentation. I didn't want to go into details because maybe people will hate me, but yes, you brought up a very, very good point.
With DAI, which is the collateral? Do we have many collaterals? I saw that we had Ethereum as a collateral, but
many. So
okay, that's. I think with Luna we had just only Bitcoin as a collateral. right?
I mean, I'm not so familiar. My knowledge is all Ethereum and Bitcoin. So the main ones, I'm not sure, but at least I think this was 0.8 billion? No, million? I don't remember. Sorry. A big value. I think billion. 0.8, more than one. I think this was 2. So there is a lot of collaterals on this, and this is the current version of DAI. So if you look it on Etherscan, you search in the address bar for DAI, you will find the contract that has this locked. But the previous version, which was called DAI and now has been renamed to SAI, SAI means single asset DAI, had only Ethereum locked in. So they wanted to upgrade it so that if the Ethereum price collapses, the crypto dollar doesn't collapse.
Thank you.
Very good question, thank you. Yes?
Address? So you show a DAI contract address, or it means that someone deployed this contract
Yes.
at some point. So who did that?
So, yeah, I mean, I don't know the guy exactly by heart, but it's probably somebody in the MakerDAO Foundation. But the nice thing about smart contract is that you can deploy them and not be the manager of it. So you can deploy a contract, people use it, but you don't have the power to remove the crypto. So there is no single point of failure in the person that deploys it, that puts it on the blockchain.
So can we audit the contract? Do we have the code?
Yes, because it's blockchain, it should be open source. Of course, people decide to have their applications partly open source because they need to be deployed as contracts, but they also can have like the application layer hidden, but for sure the contract need to be public. So if you go in the block explorers inside the Etherscan, you click on any contract and there is one tab called code that contains the open source code. Simplified, there's a bit of nuance there, but they are all open source.
And the last question, do you think on the contract there is kind of a group of administrator, or is a DAO that manage the governance?
Sure. So the contract is yours. You deploy this piece of code and you can put whatever rules you want. So you can have it completely decentralized, no rules. So if it gets hacked or, I don't know, something bad happens, everything gets stolen or disappears or crashes. Unfortunately, there are horror stories about these kind of things. But in general, yeah, it depends on the rules that are written inside the contract. You can have a manager that, in case of emergency, removes the funds. But as you said, you can audit the contract. If you're not comfortable in putting the money inside that contract, you don't, because you are a developer, so you have the power to see what's written on the blockchain and which rules are there.
Since Applied Blockchain is a company that deals with blockchain projects, how can a blockchain company protect themselves developing blockchain projects, dealing with the tokenomics? Because I've seen multiple cases where the contracts were audited by some company and they had like failures and they were hacked and lots of people got their money stolen. How can you...
I think I have 7 minutes. I could try to make a synthesis of it, but it's a loaded question, so very good question. It's pretty loaded. I could respond in many ways, but the easiest is, if you are building something that is already there, use open source code that already has locked a lot of assets into it. So if that code is 100 million secure, then probably that code is secure. So if you do just a delta of it, a very small delta, only that delta needs to be audited. I could go into more details, audit, etc., but then my CEO that watches the recording will... So I don't know if it's the right idea. But yeah, very good questions, indeed.
Thank you.
I think it's still 5 minutes, but running out of battery gas.
After you deploy the contract, can you update it?
I mean, no. Short answer. You have to build in an upgradable contract logic into the contract, but that's subject to hacks. You can imagine that it's only you that have the private key that can update the contract. Somebody can steal your private key, update the contract, and take all the money. I mean, I don't know. It depends on how you have this layer of upgradability in the, implemented, but that's what can happen, and that's what happened a numerous amount of time. And that's the best, because the auditors say, oh, by the way, the upgradability is subject to this and that. And everyone says, yeah, but no one will steal this key. Oops. Four minutes. Any more questions? I don't know. By the way, if you have more questions, @MakeVoid is my Twitter handle. I have DMs open, so yeah. I mean, I will try to respond to every one of you, but yeah, if it's a good question. Sorry. Yeah, I think that's it. Thank you.